All right, hello everyone. Got another crazy physics problem here. So what we're dealing with a certain concept that you might learn in your later physics classes called work. And work is basically we measure it in units of energy, and it kind of tells us how hard is it for something to happen. How much work does this process cost? How much energy does this process cost? So work we define as the dot product between these two vectors. And you don't even really need to know what they are. This is really just an experiment in dot products. So we can just take this. This is some kind of formula that we'll hang on to. And then it's saying, suppose we have a constant force that is equal to 4I hat plus 6.5 J hat. It's constant because it doesn't depend on time. And then we want to push this object a distance of 6 units in the I hat direction, 2 units in the J hat direction, and -1 units in the K hat direction. So if I'm being really careful here, I should 0 K hat for my force vector. So we have some kind of object, and it's experiencing this kind of force. And we want to know how much work does it cost if I want to push this object in this direction. Whoa, whoa, get out of here. Okay, so we just evaluate the dot product. F dot D equals W equals 6 times 4 plus 6.5 times 2 plus 0 times -1. That's going to be 24 plus 13 is 37. And you don't need to know this, but the units of this would be joules. So we're just taking a dot product. And then for part B, we want to know the angle between these two vectors. So we want to know what is the angle between them. So for that, we can use our other handy-dandy dot product formula. So we know that the work equals F dotted with D. We already have the one way of doing it, and that's Fx dx plus Fy dy plus Fz dz. But we also know that we can evaluate the dot product using this formula. Magnitude of F, magnitude of D, times the cosine of the difference of the two angles. So I'll call it theta F and theta D, the difference between the two angles. So I know this whole thing has to equal 37, because I already evaluated this one. So I'm going to need the magnitude of F. I'm going to need the magnitude of D. This equals the square root of 6 squared plus 2 squared plus 1 squared. Oh, and that's going to come out to be the square root of 41, maybe? 6 squared plus 2 squared plus 1 squared. Square root of that is 6.4. And the magnitude of D, following the same formula, 4 squared plus 6.5 squared, square root of that. This equals 7.63. So then we get that the cosine, I'll call it delta theta, the difference in the angles, equals 37 for the dot product, divided by 6.4, also divided by 7.63. And that comes from this term right here, dividing that off. So then we get delta theta, taking the inverse cosine of all this, we get the cosine inverse of 37 divided by 6.4 divided by 7.63. And I get that the difference in angle is 40.7 degrees. Okay, so we're dealing with this concept that you haven't dealt with called work, and it's defined as a dot product between these two things. But you haven't seen this before, but it doesn't really matter. We know how to take dot products, so we can figure out what the quantity of this W is. We evaluate our dot product directly using our Cartesian method, and then we ask what is the difference in the angles. And so for that one, we can use this other definition of the dot product, and we can solve for the difference in the angle between these two things pretty easily. And that's it.